All right, we're going to be doing the next section and the last section, 9.7. This is going to mix in some algebra review with it. It's using quadratics with circles and the algebra review. We're going to do some problems together, and this entire lesson we'll be doing examples as their explanation, okay? So we're going to do some Algebra 1 review. So those of you who are really good at Algebra 1, you'll be really happy with this. Some of you who are a little iffy on your Algebra 1, this was a great review for you, okay? We're going to do 1 through 25 odd together.
Neither.
This is our algebra review. You're going to need this for the next chapter. A quadratic is anything with a squared variable as the highest exponent. So you would never have an x cubed or an x to the fourth or the x to the third, but you will have a variable squared. That will make it a quadratic. So this right here that you have here is a quadratic because we have an n squared and nothing higher than a squared on the variable. We're going to take out the greatest common factor or factor something out. So right now there's only one place that there's a letter, so we can't take any letters out, but we can take out the greatest common factor of the number. So we ask ourselves, what can be divided by both negative 10 and negative 4?
What can be divided
the
by
highest that can be divided out without a remainder. Negative 2. So I write negative 2 out on the outside, and then I put a parentheses, and I ask myself, if I divided everything by negative 2, what would be left? So if I divided negative 10n squared by 2, what would be left?
5n squared.
I had 5n squared. And what if I divided the negative 4 by the negative 2? What would be left?
Positive 2.
Positive 2. Now you can also look at it another way. This is the backwards of the distributive property. You could have asked yourself, negative 2 times what would equal negative 10n squared? And that would have been my 5n squared. Or negative 2 times what will equal negative 4? And that would be the 2. This is my answer.
Are we doing number 2?
We're going to now factor this one. This one's a little bit different than the factoring out the greatest common factor. And I'm going to teach it to you, and I'm going to pretend that you have never seen this before, okay? And I teach it in a different way than some other math teachers do. I teach this with what's called the box method, okay? I teach it with the box method. I think when I was learning it, I didn't learn it with the box method, and when someone showed me this, I was like, oh, that's so much easier, all right? So the box method goes like this. Anything that's in the very first term, the squared term, gets put in here. And anything on the last term gets put in here. And the middle term is on the diagonals. Let's do them together and find out how to do this. What multiplies to make n squared?
N.
N and n. So we're going to put that, be careful, not M&Ms. We're going to go n and n. We put the squared term down here, okay? Before we go too far, what multiplies to be 20? And I'm going to just write the possibilities. What multiplies to be 20? 10 and 2.
5 and 4 is what we're
And 5 and 4. All right? So we now have to figure out which one of those we're going to do.
5 and 4.
I heard someone say 5 and 4, but I'm going to pick the wrong one to show you what happens when that, okay? So don't write this down, okay? I'm going to put a 10 and a 2 right here, okay? And I'm going to check the diagonals. This makes 2n, and this makes 10n. When I add them, which you will always do, I will get 12n. And that is not what I'm looking for. I'm looking for 9n. So I am going to now put in what's supposed to be there. Let's put the 5 and the 4 in. 5 and 4. Check my diagonals. I will get 4n and 5n. And when I add them, I will get 9n, and that is what I'm looking for. All right. So what's my answer?
N plus 4.
Yes, I'm going to do it in blue. It's the sideways, n plus 5. You can do n plus 4 first if you wanted to. N plus 5 and n plus 4. If you multiply that together, it will equal n squared plus 9n plus 20.
So you don't have to even have to do anything with the 9n?
No, because the multiplying it all out, if when you multiply what I always called the rainbows, that would have been the 5n and the 4n.
Reverse should be.
That when you're doing the distributive property, that's correct. Those will combine the like terms to make the 9n. Okay.
What do we do when we run into a negative? Remind me.
Good question. Let's do it. Hopefully, there's one on number 5. Is there a negative one?
It is.
Okay.
Oh wait, never mind. I remember.
So here we go. Let's do
Well, it's a little different way of doing it.
number 5 has a negative in there. That's great. We're going to do this with the box method. Here we go. I'm going to draw my box. What multiplies to be x squared?
X and X.
X and x. Now the 45. 45 is what? What makes 45? 9 and 5. And I'm going to say 3 and 15, okay? If you didn't remember that one. We have to pick something when we do our diagonals. We're going to get negative 14.
Mm-hmm. But we have a positive 45, so they both need to be negative to cancel out when we're multiplying, right?
Oh, so actually we should have thought of that, because this could be positive 9 and positive 5, or negative 9 and negative 5 will also make a positive 45 when we multiply those two negatives together, right? Mm-hmm. And same with the 3 and the 15. And so what are we going to use, the 9 and the 5 or the 3 and the 15?
9 and 5.
The 9 and the 5. And how are you able to know that without doing the diagonals and checking, Heidi?
Because they add up to 14.
Because they add up to 14 when we do it. So are they going to be both negative or both positive?
Both
Positive.
negative.
Yeah, that's right.
We're going to do, if I did this really quick, if I do what she said, both negatives, and if I check my diagonals, that's going to be negative 5, x. That's going to be negative 9x. When I add those together, I'll get negative 14x, and that is what I'm looking for. But how do I get the positive 14? I still don't get it.
What positive?
How are we going to get the positive 45? I'm sorry.
Because
Because negative times negative equals positive.
Very good, because a negative times a negative equals a positive. What's my answer?
x minus 9 times, or in parentheses,
Uh-huh.
x minus 5.
Yes, and we got that by going on the sideways. Okay. If I multiply that out with the distributive property, I will get x squared minus 14x plus 45. Let's do another one. This time, we don't have just a nice little x squared, we have a 5x squared. So it won't just be the same thing twice. What multiplies to be 5, by the way?
5 and 1.
5 and 1. So I'm going to have a 5x and a 1x. And here is where some guess and test is going to have to take place. It's not going to be as easy just to see where they're going to go. And your 6, we have 6 and 1 and 2 and 3. You're going to have to test these because your diagonals aren't going to be as easy this time. Does anybody want to pick either the 6 or the 1 and the 2 and the 3? Does anybody have any ideas? You want to do the 3 and the 2?
Yes, ma'am.
I'm not gonna. Don't tell me which one because I want to maybe mess up. So don't write this down. I'm gonna do the 2 here and the 3 here. What about negatives and positives? Should they both be negative or both be positive or what?
Both be negative.
How do you decide that, Nariah?
Because there's a negative in the middle and not in the back.
Okay, so this number right here, these positive, says that it's going to be the same, either both negative or both positive.
Yes, ma'am.
And now this tells us which it is. It's both negative. All right. So I'm going to put a negative here, and I'm going to check. I think this might be wrong, but I'm going to check my diagonals. This is going to be 10x, negative 10x. And this is going to be negative 3x. Do I get what I want? No, I do not get what I want. I want a negative 17. Now, my other possibility is to flip the 3 and the 2. Put the negative 2 up here and the negative 3 down there. And if that doesn't work, I can put the 6 and the 1 in. So here we go. I'm going to do that diagonal. It's going to be negative 15. and this diagonal is going to be negative 2x. Is that going to give me what I want?
Yeah.
Yes. So now I am ready. Those are my answers. X, oh, be careful. 5x minus 2 and x minus 3. We are factoring quadratics, and this time the number in front of the x, or the coefficient in front of the x, is no longer 1. It is something bigger. Number 8 is very similar to that one. Let's move on to number 9. Number 9. We have to put the x squared term in the first column. What multiplies to be 7x squared? 7x, yeah, 7x squared.
7 and x.
7, 7x and x. What about the, now be careful, because 6, don't forget you can do 6 and 1 along with the 2 and the 3. What do you want to pick first, 6 and 1 or 2 and 3? I heard somebody say 6 and 1. Does anybody want to try the 2 and the 3? You think so?
No, yeah, the 6 and 1.
Now, this is what, I've had a lot of experience with this. So I know that it's going to be the 6 and 1.
Yeah, I don't.
Because I got to get something close to 42.
Yeah.
7 times what gives you close to 42? Is it?
6.
It's a 6. Because 7 times what gives me close to 41?
42.
42. So that's kind of what I do also. You could do the 2 and the 3 and start to do the guess and test, and that will be what you'll need to do if you until you get some experience. But the 7 times what gives me close to 41 is what I'm going to do, and so I need to put the 6 there so that when I do the diagonal, it'll be there. And are they going to be both negative, both positive, or opposite?
One's going to be positive, one's going to be negative.
Now the question is,
The 1.
the one's going to be what, negative or positive?
Negative.
Yes.
Because you need to go down 1, so.
Because it's got to go down 1, and it's a positive 41. So this gives me my positive 42x. This goes down 1 from there to be negative 1x. That will give me my positive 41x. The larger of them has to be positive, okay? This is a lot of logic reasoning in your head to do all these things. What is my answer?
X plus 6.
X plus 6, I agree.
7x minus 1.
When you are doing your homework, if you would have written 7x minus 1 and x plus 6, you would have got an F on that assignment. Is that true?
No.
Wait,
No, I'm teasing. You would have got it that totally wrong. No, you wouldn't have. These are the same answers. You can give me either one of
I
these.
was about to erase my answer.
No, no, not at all. I was just trying to give you a hard time. They're the same answer if you give me the x. That would be crazy. You'd have to figure out which. Does Mrs. Stotts feel like an x plus 6 first or 7x minus 1 first? No wonder. Let's do another. Number 11, we are now adding one more thing. It's no longer an expression. It now is an equation. It is an equation that equals 0. We're going to now solve this equation.
How do you want us to, do you want us to do a decimal place or just a square root sign?
We'll just have to wait and find out. You are not going to multiply this out.
Oh.
Not going to multiply this out.
Okay.
There is something super cool that happens right now, and you won't have to give me any decimal at all.
Oh.
When you have two numbers that multiply together and equal 0, that's exactly what you have here. We have a number here, another number, and when we multiply them, we get 0. If I had two numbers, one of them's 3, some number we don't know, and it equals 0, what does this one right here have to be?
0.
3 times 3 doesn't give me 0. It has to be, the only way to get 0 as an answer when you're multiplying is if there's a 0 in the original. I could have also, 0 times 0 will also give me 0. So one or both of them must be 0 to be able to get a 0 as an answer when I'm multiplying. There is nothing else that would work. We're going to use this property, which is called the 0 property. Since we have a 0 up here, we know that these have to equal 0. So we know now that r plus 2 has to equal 0, and r minus 3 have to equal 0. So what plus 2 gives me 0? negative 2. Or we could have subtracted the 2 to the other side. What minus 3 gives you 0? Or add the 3 to the other side. We'll have 2 answers for this. I hope that you can look at this and not have to do this intermediate step here
Yeah.
and just jump to the answer. Let's do number 13, excuse me.
We did 12.
This time it's not factored for you. We now have to do some intermediate steps. We're going to have to do the box method and then do that thing we did on the previous problem. So what times what gives me n squared? N times n. And what multiplies to make 14?
7 and 2.
Be careful, do not forget the 14 and the 1. Sometimes that you'll need it. Which are we going to use, the 7 and the 2 or the 4 and the 1?
7 and 2.
7 and 2, I agree. But 7 plus 2 is 9, not 5.
It's a negative, so you're going to make that a negative 2.
Minus. Which one's going to be the minus? The 7 or the 2?
2.
I disagree. We want a negative 7.
You want a negative.
5, excuse me, negative 5. So we're going to have a negative 7 to make the positive. Wait. Negative 7, because this will become, these two will become negative 7n, and this will become, that will become 2n. We want a negative 5n. So we're not done this time after we factor, though. We're going to have an equal 0, n minus 7, and n plus 2. If you can't jump to the answer right here, that's not a problem. You could write out n minus 7 equals 0 and n plus 2 equals 0 if you need to.
Isn't it just 7 negative 2?
The answer is 7 and negative 2, yes. I'm hoping that eventually, after you practice enough, that you will be able to take this one and jump to the answer right there instead of having to write that intermediate step. I wouldn't require you to write this one if you can jump. Okay, thank you for letting me know. Let's do number 15.
6 squared equals,
6 squared equals,
is it, no, it's not 1/2. Is
What?
it 1/2?
it's not 1/2. 1/2 is the one we
Oh,
do the
X.
arcs.
Open parentheses, x plus.
Yes. So, yeah.
Okay, but we're doing number 15. We just got started writing the equation. Okay. Sorry, I'm not going to sit down. I keep thinking, but I have to jump. All right, so we're going to do the distributive property. This does not have a squared on both sides to take the square root. So we're going to come out here and make that 36 equals x squared plus 5x. Previously, or before today, anything that had a squared in it canceled on both sides. Today, this one does not, because I just taught you how to solve quadratics by factoring. So what did we have to make a quadratic to solve it by factoring? Do you remember? It had to equal something.
0.
It had to equal 0. This one equals 36.
0 equals x squared plus 5x minus 36.
That's correct. We're going to move that 36 over to the other side and have 0 on the other side by subtracting the 36 to the other side. So we're going to have x squared plus 5x minus 36. I don't care if you put the 0 over here or over here. I'm running out of room. What do I do now?
Box.
Box method. All right, so we're going to do the box method. What multiplies to make x squared?
1, 6, and 6.
Careful. X squared.
X and X.
X
Oh,
and X.
sorry.
You're okay. You're ahead of us. All right.
I had 4 and 9 though.
What about 36? 9 and 4,
Or not.
6 and 6, 2 and 18, 3 and 12, woo! And 4, oh, got 4, okay, got them all. And then 1 and 36. And
I did 9 and 4.
She's
9 and 4? Negative 9, negative 4, both the same, both different?
Negative 4.
I mean negative 4.
Negative 4?
And a positive 5.
Okay, so negative 4 and positive, 9. I agree, because when we do our diagonals, we're going to get a positive 5x. So now, what goes in this parentheses?
X plus 9.
X plus 9, x minus 4.
So is this the answer?
No. We want x
Okay.
equals something. X equals
Negative 9.
-9 or 4. Which one of these does not make sense based on the diagram up here?
Negative 9.
The -9 does not make sense because we're looking for a length. A negative value doesn't make sense. Mathematically, we are able to get a negative 9, but it doesn't make sense. So my answer is x equals 4. Questions? Let's do another one. Number 17. How do I find, what's the relationship between that 12x and the 16 and the 9x and the 27?
16 times 27 equals 12x times 9x.
16 times 27
Mm-hmm.
equals 12x times 9x.
All right. What is 16 times 27? I did not memorize my 16 times tables.
432.
432 I heard.
Yeah.
Somebody verify that. Got it? What about 12x and 9x?
108x.
108x? Careful, not 108x. Squared.
108x squared.
This is a quadratic, but does not require that we do that box method because I don't have an x and an x squared. What am I going to do for this?
Take the square root of both sides.
You can. I'm going to move the 108 over first, though.
Huh?
I'm going to move the 108 by dividing first.
Oh.
Does 108 go into 40?
X.
132?
Yes, 4 times.
Oh.
Oh. What's this? Wait, what? 32. Yeah.
So this time I didn't need that box method because I could just solve it by taking the square root of both sides.
Yes, ma'am.
X equals how much?
2.
Yes. All right, let's do number 19.
Well, 18 looks weird. It looks almost like a 17, but it's not. It's a 1.
All right, number 19. Remember when we're doing these, it's the outside times the whole equals the outside times the whole. What is the outside on the top one?
X, open parentheses, x plus 11.
Okay, so that is our outside, and the whole thing is the x plus 11. Equals the outside of the bottom line, which is, and the whole,
6 plus 15.
6 plus 15. If you want to write what 6 plus 15 is, I don't mind that, or we can write 6 plus 15. I'm going to write what it is. What is 6 plus 15?
I don't know.
21.
21.
That's times.
All right, I am going to do the distributive property here. This is going to be x squared plus x.
X squared plus 11x.
Oh, that's 11x. Thank you. It looks like a 1 there for me. I'm sorry. Thank you, thank you. And then I don't know what 6 times 21 is. It's 100 and...
26.
Yes. Is this going to be a box method, or am I going to take square root of both sides?
Box method.
How do you know?
Because you have x squared and an x.
An x squared and an x. That's correct. So I'm going to move that 126 over because I have to have an equals 0 to do that box method. X squared plus 11x minus 126 equals 0. I do not know what multiplies to be 126. We're going to have to do some playing around with our calculators.
126. Well, what adds to be 11?
Lots of things.
1 and 11, 2 and 9, 3 and...
Well, let's see. Does 2 times 9 equal 126? No.
No, but
So
4 plus 7, 5 plus 6. It's got to be something high.
I know it does. None of those things are very high.
But something subtracts to be 11. Bunches of things subtract, and it's going to have to subtract. They're going to have to be opposites. So I would like to do the 126. I know that 2 goes in there. 2 and 63. And 9 and 7. So the reason I did a factor tree is because now I can do 9 times what gives me 126? 14. 9 and 14, does that make 11? No. 18 and 7. Because what I can do is I can multiply in all these in any order. I can go 9 and 14.
Mm-hmm.
I can go 18 and 7. I could do 63 and 2. Which of those make 11?
18 and 7.
18 and 7. Okay, so is it going to be
Negative 7.
X and X by here? And 18 and 7. Which one's negative?
7.
Right. X minus 7 and X plus 18. Don't forget your equals 0. X equals what?
7, positive 7.
I heard 7 and negative 18, correct?
But we're only going to do the 7 because it doesn't make sense to have a
Negative value.
negative value.
So the answer is just going to be X equals 7. All right, let's do number 21. All right. This is new. Not new to you maybe, but new to geometry class, okay? We have not seen some like this, and we will need to do reducing fractions with variables in them, all right? And this is all has to do with exponents.
Isn't that the same thing as the other thing that we did where you have to like take it out to the side to get the exponent away? Or is that a different?
No. Well, let me, it might be, I'm not quite sure, but let's do this and then you'll be able to tell me if it's the same. If there's a number in front, like the 6 and the 9, you just reduce those like you reduce all fractions. What can I take out of both 6 and 9?
3.
So if I divide the 6 by 3, I'll get 2, excuse me. And divide the 9 by 3, I'll get 3. Okay. Now we have to do the letters. All right? I'm going to, you don't write this part. This N, there's an N on top, and there are 3 N's on the bottom. And they cancel it out. So what will be left? N squared, okay? You do not have to do this part at the bottom, but I want you to kind of see a visualization. What could you have done with n to the first power and n to the third power to get an n to the second power? Subtract the exponents. How do you know if the n squared was going to be on the top or the bottom when you were done?
Wherever there's leftovers.
Wherever there's leftovers, and there were going to be leftovers on the one that's got the largest amount of them. All right, so there's 1 on the top, 3 on the bottom. There will be 2 left on the bottom. Is this similar to what you thought it was going to be, Amy?
No, not really.
It's not. I think maybe you're thinking about the rationalized.
I think I was thinking of, like, the steps are different, but it looks like the same setup.
Okay, right. Let's go on to number 23. Does anything cancel? Be really careful.
The P and the P squared.
No.
The P and the 3P.
The P and the 3P,
So
she
it's
thinks.
gonna-
Yeah.
Oh yeah, that's right.
Don't write that down. Don't write that down. All right. The only time you can cancel in a fraction is when 2 things are multiplying together. Never, ever when they're adding and subtracting. So we have to figure out what is multiplying together to equal the P squared plus 3P plus 2. We have to factor this out. So we got to use a box method on this.
Yay.
Yay! That box
Actually,
method
it's
thing.
really good, Brett.
All right, so what P squared and becomes P and P, right? But what about the 2?
2 and 1.
2 and 1, are they both added, both subtracted, or opposite? Actually, or, yeah, they're adding, right? I did say that correct. Are they both negative, both positive, or opposite is what I was meaning? And they're both positive. So I'm going to have a p plus 2 and a p plus 1, and on top I still have a p plus 1. What can cancel now? Since the p plus 1 on the bottom is multiplying to the p plus 2, and there's a whole p plus 1 up there, I now can cancel those out.
So it would be 1 over p plus 2.
Very good. Don't forget that there's a 1 on the top there over p plus 2. The trick to this one is going to be remembering that you have to be multiplying to be able to cancel out. You just can't start canceling out 1s and 2s and 5s when they're not multiplying because they're adding there. Okay. Last one, number 25.
We're doing 27, aren't we?
Number 25. What am I going to do to the numerator or the top of the fraction?
Factor it out.
Factor it out by using the box method. All right, what goes in the first column?
2 p's.
2 p's. A p on the top and a p on the bottom. What about the 80? What multiplies to be 80?
8 and 10.
8 and 10. Will 8 and 10 somehow become 18?
Yes, ma'am.
All right,
Yeah,
both
19.
negative. Okay, so how are we going to make it?
Both negative.
negative.
Yes, both negatives. All right, so what will that become for my numerator here?
P minus 10, P minus 8, but both of those are in separate parentheses.
Yes. Now, am I going to just write 8p minus 64 over here?
Factor that, but I don't remember how. We did that out.
We did that on the very first problem when we were doing our factors. What can I take out of an 8 and a 64?
Oh,
I can take out an 8?
Yeah.
What will be left? Or
P minus 8.
how did you get that so fast?
I don't know. She's hurting my brain.
Squares. 8 times 8 is 64.
Okay, so what I'm going to ask is 8 times what will give me the 8p?
You're fine. You're fine.
8 times what will give me 8p?
8 times p.
Yes, so it's just a plain old p right there. Or you could have thought of it as dividing. 8p divided by 8 was just p, right? 8 times what gives me 64?
8.
8. Can I cancel anything now?
The 8 minus p.
P minus
The 8,
P
yes.
P.
What will be left?
P minus 10 over 8.
Very good. You must factor. They must be pieces that are multiplying together to be able to cancel them. Can I reduce the 8 and the 10?
No, because it's not multiplying.
Because you're not multiplying. You're actually subtracting that 10 up at the top. That's great. Good. Good, good.
She better not say that this isn't one, I swear. No,
We
we
have
to
just
use the box
concluded-
method, and it'll end up being 1.3.
All right, we just concluded. We did quadratics with circles, and we did some algebra review to be able to do those quadratics. Okay? We're finished. I hope this was helpful. Goodbye.